Welcome to our training series on Intel's next-generation firmware initiative, the Universal Scalable Firmware, USF. For this session, we will dive a bit deeper into the operating system interfaces. The goal for the system firmware, or BIOS, is to pass control to an operating system. This section is an overview of some of the well-known OS interfaces supported by Universal Scalable Firmware. The OS interface will support OS boot protocols such as UEFI, Linux Boot, Multi-Boot, and Acorn. For the OS interface, the USF bootloader will prepare the underlying functions and protocols required by the desired operating system. For example, with a UEFI-aware OS, the bootloader will create runtime services, data tables, configurations, and variable services. Other OSs may require additional protocols and interfaces as listed on this slide. How does the USF bootloader provide information to the OS? First, a bootloader, or BIOS, will initialize for modern computer buses and devices such as PCIe, USB, SATA, etc. This initialization includes support for software detection, enumeration and configuration, providing true plug-and-play capabilities. However, there still exist some devices that are not enumerable through software. While it is possible to write platform-specific device drivers to support such devices or interfaces, it is more efficient for the platform-specific firmware to provide information to the platform-independent operating system. There are two data protocols that are used extensively for this purpose, ACPI and device tree. Some OSs will also use the SM-BIOS data structures for information about specifics of a platform. This concludes our dive into the operating system interfaces. For our next session, we will take a closer look at the universal payload.